Okay, today I'm going to talk to you about combustion. We're going to look at the difference between complete and incomplete combustion. So first of all, it's important to know that combustion is the scientific term for burning. And in order for combustion to occur, we need to react with oxygen. Now, the first type of combustion we're looking at is called complete combustion. Complete combustion occurs when we have plenty of oxygen, a really good supply of oxygen. So we're going to have a look at an example. Now, hydrocarbons make great fuels because when they undergo these combustion reactions, they release lots and lots of energy. So a hydrocarbon is just a molecule comprised only of hydrogen and carbon. So here's the equation for complete combustion. So when we react a hydrocarbon with oxygen, we get two products. We always get the same things: carbon dioxide and water. And like I said, the whole purpose of this reaction, or we could use this reaction, is in fuels to release loads of energy. So the hydrocarbon you could use could be petrol in your car. Now, I'm just going to show you an example underneath, just to show an example of a symbol equation. So let's say we had a hydrocarbon of methane, contains only carbon and hydrogen. We react it with oxygen and we get carbon dioxide and water. I'll just quickly balance this. Okay, so as you can see, these are the two products we always get during complete combustion, when there's a good supply of oxygen. Remember, carbon dioxide contributes towards global warming. So that is one of the negative aspects of one of the products here. But it's preferable to incomplete combustion that we'll see in a second. Now, it doesn't matter which hydrocarbon you have. It could be one with 10 carbon atoms instead. We'll always get carbon dioxide and water. The only thing that will differ is how many of each molecule that we'll actually get. So that's complete combustion. Now we're going to have a look at incomplete combustion. So it completely makes sense that complete combustion is when we have plenty of oxygen. Incomplete combustion occurs when we have not enough oxygen. And incomplete combustion does not release as much energy at all. So incomplete combustion is a little bit more tricky because we don't always get exactly the same two products. I'm going to show you one example of incomplete combustion here. So let's say I have hydrocarbon again. Again, these are great fuels. Again, we're reacting with oxygen. Combustion needs oxygen in order to occur. Now this time, I might have these products instead. Carbon plus carbon monoxide plus water. Now, in reality, during incomplete combustion reactions, I'm going to have a mixture of carbon dioxide, carbon monoxide, carbon and water. But the important thing is to know that we do produce, during incomplete combustion, these two substances are produced here. Carbon, which is basically like soot. If it gets released, it can go onto buildings and make them really black and dirty. And it can also cause respiratory problems if inhaled by people. Now, the really serious product that we need to know about is carbon monoxide. Its formula is just CO. If this is produced, then we can have some really, really serious consequences, such as fainting, coma, or death. It's a poisonous, odourless, colourless gas. Now, the reason why we need to know about this is, let's say you had in your home you had a faulty boiler, and it wasn't doing complete combustion. Because it's faulty, it wasn't getting a plentiful supply of oxygen. Carbon monoxide could be produced, and that would be, if you're inhaled, it could potentially be fatal and kill you. So this is why it's so important to have a carbon monoxide sensor in your house in case your appliances undergo incomplete combustion due to being faulty. The last thing we really need to know about both of these reactions is they are both exothermic. So they both release lots and lots of energy. And this is the reason why combustion reactions occur during fuels, because when we burn fuels, we release the energy. So that essentially is the difference between complete combustion and incomplete combustion. Thank you.